Chippy, December 2014. We have two talks tonight, and our first one is a fellow at the Python Software Foundation and product lead for Python at Heroku and author of many open source tools, including requests. Please give a warm welcome to Kenneth Reitz.
Hello, everybody. How are you guys doing tonight? What was that? All right.
Awesome!
Nice. Hello. My name is Kenneth Reitz, and if you want, you can follow me on Twitter at Kenneth Reitz. And I work for a company called Heroku. I believe that Heroku is the best place to deploy Python applications, and it's also a great place to deploy applications written in all kinds of languages. So they're the reason that I'm here tonight. They paid for me to come out and speak to you. And if you'd like to learn more, come talk to me afterwards. I'm also a member of the Python Software Foundation, and we recently changed the way our membership works during PyCon this year. And basically the way it works now is before you had to go, and if you wanted to become a member, you had to get voted in, and it was this big bureaucratic process, and it was kind of very exclusive to a small group of people. And now we've changed it so that anyone who wants to become associated with the organization just goes and signs up, and you're a member, and you can join all the mailing lists, and it's open to the public. So if you care about Python, and I assume you do because you're here at this meetup, I would encourage you to go and sign up because you can go and help kind of shape some of the discussions behind the organization that's responsible for ensuring the longevity of the language, which is a big deal to me personally, and I assume to everyone here as well. So if you know who I am or what I do, it's probably from the open source code that I've written. My most popular project is called HTTP for Humans. And basically what it is, well, we're going to get into that in a minute, so I'm going to skip that for now. I also have another project that's pretty popular called HTTP bin, which is like a mirror, basically, for setting HTTP requests. So as I was writing requests, basically, you want to test all these different HTTP clients, like you have curl and urllib2 and all these other things written in other languages, and you want to see like what their default, just when you're sending a request, you want to see what happens. If you're using like Chrome or something too, there's all these headers that are set and all these other different things that you want to test for and just see what's going on. So this service just responds with what was sent to it. And it can also respond with some different challenges. So you can like say, give me, basic authentication challenge response, give me a 404, give me a, whatever you want. And it's pretty useful. I have a lot of other projects, including one called OSX GCC installer, which makes Apple's lawyers nice and mad, apparently. They gave me a call one day. Basically, that allows you to install GCC on your Mac without using Xcode back in the day. And I had to kind of ignore a couple of licenses in order to do that. But it was really great because they called me on the phone and we started talking. And now if you go to install the Xcode, you only need to install the command line tools for Xcode. And that was like a collaboration with Apple, so that was pretty great. You're welcome. So instead of like a 6 gig download now, it's like 200 megabytes. Thanks. So I am a firm believer, for me personally, of open sourcing all of the things. I've gone so far as to open source my some of the, I can't remember what it's called. I call it my genome. I know it's only a subset of it, though. It's like the polyphase or something like that. But if you go to github/KennethWright/genome, you can download me, and there's a license and everything. It's pretty fun. But I like to treat all projects like they're open source, even if they are going to be closed source. So this really kind of allows me to approach things in a really different and beneficial way. So when you treat a project like it's open source, and say it's an internal project for your company, basically, an open source project wouldn't be very successful if it wasn't very concise and decoupled from other things. Usually a good open source project does one thing really well, or a couple things really well, but it's focused on one problem set. And often when you're working internally at a company, it's very easy to kind of branch out and have this piece of code solve all the problems and stuff. So I like to build things, pretend that they're open source. And this allows you to really kind of separate concerns from one another. And when you do this, a lot of best practices emerge. So for example, if you were going to go and develop a Django site that you were going to use internally, oftentimes people put all of their database credentials right into the repository, which you should never do, which is terrible. It sucks. Don't do that. so if you pretend that the project is open source, you would never have done that in the first place. You would kind of approach it from a best practices perspective. In that vein, documentation also is really, really important for open source. Basically, if you have a project and it had no documentation, no one would use it. And the same really counts for your internal projects as well. You need to sell, at least from a documentation perspective, here's why you should use this thing, here's how you use it, here's why it's easy to use. So if you write documentation, you write tests, these things all kind of just naturally start happening. And the benefit of this is that if you are going to release the code at any time as open source, you just can flip a switch. You don't have to go through any process to ensure that there's no credentials in the code, because ideally those wouldn't be there in the first place. So let's get a show of hands. Who here uses Python? Cool. Really? Some people don't. That's awesome. Raise your hand if you don't use Python. I'm really curious. That's awesome. What do you guys use? Just out of curiosity. You don't have to answer. MATLAB. That's awesome. Python's a good option for you then. Anyway, so Python has a certain philosophy that really attracts a lot of developers to it, and it's kind of one of the main reasons I choose it as my primary language. It just has a lot of values that really resonate with me, basically. And we all kind of share a dark past, usually. If you write Python, you've come from another background like Perl or Java, PHP, Cold Fusion, classic ASP. I'm sure there's crazier ones like MATLAB or like Fortran, COBOL, I don't know. But we all share this dark past. And, there's all these different things that exist in these other languages that Python kind of tries to separate itself from. And the simplest way to represent this is called the Zen of Python, PEP20. So if you go into a Python interpreter and you type import this, you will see this beautiful output here, which is, the Zen of Python. You can do that in any Python interpreter. Oh, hang on, I lost my presentation. And so some of the most important ones to me that we're going to talk about today are beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated. If the implementation is hard to explain, it's a bad idea. This counts for everything except for PyPy, because PyPy is ridiculous. And this is the one we're going to focus on the most today, and it is that there should be one, and preferably only one, obvious way to do it. If you look at a lot of other communities like Ruby, they really value and put at the forefront the fact that you can take one problem and solve it in 20 different ways, which, in their worldview is a great thing. But from Python's perspective, we want to do the opposite of that. We want there to be one clean, obvious, good, pragmatic approach to every problem we have. And that's one of the things I love the most about Python. So you've chosen Python as your language that you're going to use. You read PEP20. It seems like a great option. You're going to ditch Cold Fusion and never touch it again. Welcome to paradise. It's a lie, unfortunately. That would be great, but it turns out that as a community, we actually don't follow that as well as we'd like to. And I think this is something that, PEP20 represents a set of ideals that we're continually striving towards. So we're going to take a piece of code, let's say we're a Ruby developer, and we're going to translate it into Python, and we're going to see how it goes. So basically what we have here is a piece of code that reaches out to the GitHub API over HTTPS, and it just sends a username and password, and you get a response. Pretty simple. So the way this works is you import a net/HTTP library and a URI parser. You take your string of your URL and you parse it, and then you create a new HTTP object with the host and the port, pretty straightforward, and you tell that connection to use SSL. And then you create a new GET request from that object with the URL, and you add basic authentication with the username and password. You explicitly add that. And then you send your request, and you get your response. It's very verbose, but there's nothing here that comes unexpected from working with HTTP. This is basically exactly what needs to happen at a low-level library. So the first thing you do when you go to do this in Python is you ask yourself, what's Python's version of the net/HTTP library? And you go and you're going to search on Stack Overflow, and you're going to find a plethora of different answers. There's HTTPlib, URLlib, HTTPlib2, URLlib2, the socket library, the URLlib3. There's a tremendous number of options. And basically what's going to happen is several hours later, you will come up with the de facto best practice solution using the standard library, which looks a little bit like this. You use the URL. No problem. A second. Am I still going through?
Can you hear us now?
So I should just stop moving, right? And this is kind of like the de facto best practice standard library way to do this, if you read the documentation. So you have you get your URL and you store it because you're going to have to reference it many times. And then you create a new urllib2.request object from that URL, and you call that a request. And then what you do is you create a password manager called an HTTP password manager with a default realm, obviously. And then you add your password into it with the GitHub URL referenced directly. So this appears as though you were very explicitly saying, send this username and password to this URL. And then you have an authentication manager, which is an HTTP basic auth handler. And you have to pass in the password manager into that. And then you create an opener, a urllib2 opener builder, and then you pass in the auth manager into that. And then you have something that's able to open URLs. And then what you do is you install the opener into the entire library. You actually do, it's very confusing. And then you create a handler, which you use to open the URL. And then you can read the response like a socket. And that is how you make this request, which, if you look at these two options of how to do this, one seems a lot clearer than the other to me. But wait, there's more. It's actually much more complicated because GitHub responds with a 401 instead of a 404. Basically, if you're trying to access an authenticated resource and it's a 404 instead of a 401. So the way this works is if you're trying to access a protected resource, if you say, please give me credentials, that is verifying that it exists, if it's a named resource. So instead, they give you a 404. So, it's I don't know what you're talking about until you send the right credentials. And then it'll be then it'll tell you if it exists or not. And, so this is a nice security feature that GitHub offers. And remember, if you look at this code, we explicitly told it to send that username and password to that URL with this password manager thing, but it's following the spec so closely that it's not going to send it. So we have to override that behavior. And it's nice that we have the ability to override this behavior, but it sucks that we have to. So you have to overwrite the 401 response and do this crazy stuff. And then you can finally send your request and get your response, and it works. And we're not doing any SSL verification at all. We're going to ignore that because that would be 5 more pages. But this is how it works. So admit it. If you were a Ruby developer coming to Python, and this was your first interaction with Python, with these PEP 20 people and the zen of code, you would just leave and you'd never come back. You'd think these people are full of shit, and that's it. So the problem here is that it's really unclear which module you should be using in the first place. The prognosis seems to be online to use urllib2, but the docs are really lacking, and it has a really bad API. And a lot of the code that exists within this library exists to serve itself, not to serve you, the user. And I believe this is a really, really serious problem. HTTP is kind of this core technology that we've used our whole world revolves around the web. And, if it's difficult to approach something that's so fundamental to the way we do things today, then it's a big barrier to entry for the entire ecosystem and the language. So I believe that HTTP should be as simple as the print statement. So the solution is simple. We should build elegant tools to perform these tasks. And I believe that these are called pragmatic packages. And I think that Python should have a lot more of them. So pragmatic means dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. It's really easy to kind of go down a route where, if you look at urllib2, they're trying to follow the spec to such a degree that they're trying to cover every single possible corner case and use case in this API. And in doing so, they've actually alienated all the 90% users that they have, to do this very simple everyday request requires that much code and that much complexity, I think that just means it's a really failed API design. And it's definitely not pragmatic. So these pragmatic projects I like to call Python for humans. So if you break HTTP down to its core, it's actually not that complicated. There's none of these openers and handlers and password authentication managers and default realms and stuff. If you really look at what it is when you're interacting with the web, you basically have a small set of methods with consistent parameters. You have like head, get, post, push, put, patch, delete, and you can have arbitrary ones as well. And they all accept headers, URL parameters, and body and form data. This is not like super complicated. But URLib2 is like this really over-engineered thing. It ignores all of PEP20. The docs are really hard to read, and they don't actually tell you how to do any of the stuff that we did. And this is all the documentation that tells you how to do that is written by another guy. HTTP is like this kind of simple, nice little thing that mostly works really well, and URLib2 is not. And this scares people away from Python. So I wrote this thing called requests, and I think it's a lot better. And it's HTTP for humans. So basically the same amount of code in Python now is you just import requests, you have your URL and your username and password, and you create a request object, or you just do request.get with the URL and the password, and you get your response, and that's it. Yay. Or you should talk to me afterwards. I have an idea for that. Anyway, achievement unlocked. We have a small set of methods with consistent parameters. We have a head, a get, a post, a push, a delete, all those. And they all accept headers, URL parameters, and body and form data. That's it. It's very simple. Do this. Do this for everything. The litmus test is if you have to refer to the documentation every time you use a module, then please, please, please go find a new module that doesn't do that, or build it yourself, because you're just going to save yourself and the world a lot of time. And to do so, I think it's really important to fit the 90% use case. If you're going to be doing this in an open source fashion, you'll probably have a lot of people that'll start complaining, they'll be like, oh, I have this weird job that has this weird use case this won't work for me, and they're going to complain, and it's really important to learn how to completely ignore those people, basically, because they're kind of what kills good software. Because I believe that the API is the only thing that matters when you're writing code. The kind of code I write, at least. It's the primary thing that I focus on, and everything else is secondary to that. I'm not saying those things aren't important, but they're not as important. And I mean everything. You have features, efficiency, performance, corner cases, security. Maybe not security. I don't know. That's debatable, depending on what you're doing. But everything is secondary to the API. And to do this, what I do is I start with a README. I'll go and if I'm going to write a library, I'm going to pretend that it exists already, and then I'm going to use it, and I'm going to tell someone how to use it. I'm going to give them a quick pitch on why they should use this thing in a sentence or two, and then I'm going to show them how to use it in a little piece of code, right on the home page of the repo, if you will. And I can really focus on the problem at hand and actually design something that's pleasurable to use before I've ever written any line of code or think of how it's implemented. I just want to know how to use it, and then I can go start implementing it. And this really changes the way you approach the problem. So at first, request was really far from powerful, but it really deeply resonated with people, and we kind of learned how to pivot. So the features tremendously grew over time. At first, it just did exactly what was on the board here. But the API was never compromised. As we added all these additional features and all of this wonderful functionality that's been added to the project, the API has never changed. It's been appended to, and it's become more powerful. But if you wrote code with the basic use case on day one, it still works exactly like it does today. So today, requests supports cookies, sessions, content iteration, decompression, file uploads, asynchronous I/O, keep alive, connection pooling, callback hooks, proxies, OAuth, and all kinds of crazy things. And this number is out of date. It's been downloaded at least 30 million times. And it's basically the most downloaded Python package other than setup tools itself, which is I'm very proud of that. It's great. And all these companies use it. And it's been fantastic. So cool story, bro, right? Why am I telling you all this? Am I bragging? Basically what I'm trying to say is that if you build a better API, people are going to use it. And it's going to be worth your time as a developer, and it's worth everyone else's time as well. So I really encourage everyone to, If there's this library like SQL Alchemy or something that you find very frustrating, go and do something about it. That's what this community is all about. And that's how we get to where we are. In addition to that, I think that the Python community has a lot of different barriers to entry that make it a little hard to approach the language. We're going to go over some of those. For example, there's file and system operations, which are, there's all these different modules. You have sys, shutils, os, os.path, io. I never know which functions in which library. I have to Google it every time. And this is not something that we can necessarily change right now, but these are just things that I find pain points. It's really difficult to run external commands in Python. Like really difficult. If you want to do like Unix-style programming where you're piping things around and doing stuff like that, it's like you have to use the subprocess module, which is very low level. It's just the C API basically in Python, and I think there's a lot of work that we could do in that area. And this really stops DevOps people from adopting Python. Installing Python, you have quite a few things that you have to decide on. So who here uses Python on OS X? Okay, so raise your hand if you use the one that came with the system for development. All right, raise your hand if you'd use the one from Homebrew. Raise your hand if you'd use the installer from the python.org website. Raise your hand if you built it from source. So like what happened to there being one obvious way to do it, right? Like there's something so fundamental to Python as like installing it, we haven't even come close to tackling that problem yet. And so, there's a lot more work to do. And you have to decide if you want a 32-bit or 64. And if you're building on OS X, you have to decide between a Unix or a framework build. There's just like all these options, and there's no sane default for any of us. Is there a question? Oh, yeah. Well, yeah, I'm sorry. Huh? Oh, no, it'll definitely get there. So there should be one, and preferably only one, obvious way to do it. Some other pain points, there's XML Hell. eTree really annoys people. LXML is really great, but it can be really difficult to install. Packaging and dependencies, you have to decide if you're going to use pip or easy install. And of course, if you're using easy install, there's no easy uninstall. You have to decide between distribute and setup tools. Luckily, this is kind of a solved problem now, but still people don't really know what the answer is because those are still two packages that are listed somewhere. You have to have tribal knowledge in order to know this stuff. Setup tools appears to be built into Python often. I can't remember which, I think it's an OS X. Easy install is just available, so people think it's built in, but it's not. Although that got fixed today, so I should check the slide. Or last night. Last night, Python 2.7.9 was released, which is the first Python 2 that people can use that comes with pip by default. So it's fantastic. I think it can thank Donald Stuffed probably for that completely. I'm not positive, but I almost guarantee that was him. Yeah, in SNI support as well. They completely backported the entire SSL module from 3 into Python 2. So it's very exciting. 2 lives on forever. A lot of people ship broken setup.py files. And released packages, sometimes they'll just be on GitHub and they tell you to pip install from GitHub or something, or just run setup.py install and they won't be on the cheese shop. These are just a lot of little pain points that people run into fairly often. You have date times. There's a lot of different libraries that are available in the standard library. You have date time, calendar, date util. Date util is a separate thing, but if you install date util, you need to explicitly say that you want to use 1.5 because one of them is only for Python 3 and the other one's only for Python 2, and you just get a syntax error. It's like a lot of crazy things happen with date times. Time zones, they suck. And the standard library can generate but not parse ISO 8601 dates, for example. These are really fundamental things that people, huh? Good, thank you. Unicode is a whole thing that we won't get into right now, but it's a pain point. Testing, also a pain point. A lot of people think that doc test, for example, is appropriate for very serious tests, and it is not intended to be used in that way in any way, shape, or form. Then there's the unit test library, which is built in, which is pretty good, but then you have unit test 2, which is also pretty good, and it's confusing which one you're supposed to use and which one's best practice. Installing dependencies. There's this Python MySQL library, which has 17 different names. I can never remember which one's right. It's MySQL DB Python, Python DB MySQL, and there's a bunch of crazy stuff. So once you get the name right, if you can compile it properly, good luck. There's Pill, which has been improved a lot. There's like a fork of Pill called Pillow, which is a lot easier to install and maintained. So there's, this is what, Pillow 2? Oh, Possible. Yes, exactly. In ModWizKey and LXML, most of these things are actually pretty easy to install. Like if you're on a Mac, Pill, like you need like 2 packages from Homebrew, and then it just works. But like that's not in the documentation, right? So that like is an unfortunate situation. So after all that, basically my solution to this problem, I don't think it's feasible for me to like go out to each of these projects and try to improve their documentation. So what I did is I created a project called The Hitchhiker's Guide to Python, which is available at python-guide.org, and it's an open source project that anybody can contribute to and are very welcome to. And of course it teaches you to never panic and carry a towel. But basically what it does is it documents our best practices and our tribal knowledge from our community. It serves then as a guidebook to newcomers. So if you're new to Python and you want to install it, it gives you like an attempt, an opinionated like best practice approach. That's like the obvious way to do it. And it's a reference for seasoned veterans as well. So if you're like a scientific guy who's going to go into web, it'll just like, if you go to the web section, it like tells you the 2 sane options, which are like Flask and Django, basically. There are other plethora of other options, but those are the 2, obvious ways to do it, which is great. For example, it recommends distribute pip and virtualenv out of the box and has explicit installation directions for every OS. It instills a resistance to doc test, and it teaches people to always use datetime.utc now, not datetime.now. These are things that every person who's been doing Python for a while knows, but these are things that need to be documented. So everyone in the room, I really heavily encourage you to contribute. I basically merge every pull request that is sane, which is most of them. And there's only one rule, and it's that there's one and preferably only one obvious way to do it. This makes the Python community more accessible, and it lowers the barrier to entry. It sets developers up on the right path. It is a great reference. Basically, it allows us to practice what we preach, which is really important. So the manifesto of the talk is simplify terrible APIs and document our best practices. Thank you very much.
Microphone. If you have a question, just raise your hand and I'll bring the mic over to you.
There are no bounds to the questions.
I'm just wondering what if anything, you've been learning from the Node community, and if there's pieces of that community that you think we should pull into Python.
So the Node community is really fascinating. I think it's mostly the opposite, actually, that I've been experiencing. The best things that I've seen, so there's a lot of different components to the Node community. There is organizational stuff, which I think has been very, very broken in a lot of ways. And it's great because it's being discussed. So right now what's happening is the Node community is actually splitting into 2 at the moment. There's Node.js, which is the project, which is this company, Joyent, bought Node.js from the core developer, I believe, or they bought him, and like they are the official stewards of Node.js. And basically what happened is, some people aren't happy about that. And so, for various reasons, and it's not controlled by a community. So like in the Python world, we have the PSF, which is like the official steward of Python, and it exists to ensure the longevity of Python. Node doesn't have that right now, and that's a really big problem. And I think that they could learn from us and from other, like the Apache Foundation and projects like that, to do that. And I think that's what's happening. So basically this new fork is called io.js or something, and that's the plan. But there's a lot of other things too that have been pretty great. There's NPM, which is a great tool for managing versions of Node as well as itself and like installing Node. Like their package manager you can also use to install Node itself, which is great. So you could like in your project say, I want to use Node 2, 1.8, I don't know what the versions are anymore, but some version, and it'll like download it for you. I think that would be great to have something like that. But NPM is also filled with it's crazy. Like, this is a company that runs the index, and like, imagine if the cheese shop and like Python itself was all owned by different companies and they're all fighting with each other. That's kind of what's going on in the Node world. So I feel like they have a lot to learn from us, and I feel like from a tools perspective, we have stuff to learn from them. But I really wish we would collaborate more. I feel like they're all solving problems in the dark with their community that we've already solved. And I think it'd be great to reach out to them or somehow try to contribute instead of just kind of watching this thing burn down. But that's my opinion. Sorry, there's like a lot of stuff there, but is that a good, I don't know what you were expecting.
I think I was thinking more in terms of tooling, but you bring up a lot of it. I did say community, so you answered the question I asked. The one question. I'm an old Python person who went to Node for a couple of years, and now I'm back, and I learned a lot while I was there. I really do like all the tooling, and I think NPM is something that like is the requests of package management.
Yeah, absolutely.
It's phenomenal. So
yeah, package.json is like, I wish everyone had that.
Yeah.
But so the thing for me in the Node community is like, I really wish that it's a good opportunity. Both Node and Go have this where they're like completely greenfield and like everything, they have a chance to invent everything from scratch. So like one of the most popular Node packages is like makedir_p. That's like a library, and it's like one of the most downloaded ones, which is a little ridiculous, but it's because like no one solved that problem yet. And so someone like the community solves it, there's an obvious choice, and then they can like backport it into the standard library, which is great. And so that's why I think Node is so popular, is you kind of have, it's like this, like the Wild West, you get to stake your place in the kingdom early. And there's a lot of new approaches to a lot of problems that we have. Like packaging, they really nailed packaging, I believe. And so I feel like a Python without a standard library would be pretty cool. I don't know what that would be like, but I think people should think about that stuff more than they do.
So I'm going to inject a quick question. Is Request going to join the standard library anytime soon?
No, it's not. Although it's technically in there right now. So now with this ensure pip thing that's built into 279 and 342, pip is built in by default. It's not built in. So basically, when you compile Python, it will install the latest version of pip for you. And so everyone has pip now, and Request is technically inside of pip. But you'd have to like use a weird import statement. But to answer your actual question, basically the standard library is where a project goes to die effectively. And I'm actively developing Request. It's extremely stable, but I never want to not be able to add a feature because of another bureaucratic process. And the way I see it is that and this is evident in the fact that pip is now built into Python, is that if you're going to use Python effectively, you're going to have to install packages anyway. So I don't think it's a barrier to entry to request that someone install requests in order to do HTTP. It would be great if it was built in, but it's just not. It would have to be some bastardized version of it if it was going to go in the standard library. Because I'd make a lot of choices and design decisions that Python itself couldn't use. So I ship like a CA bundle for SSL verification that's that I curate and stuff like that. And Python could never do that. So the experience of using it would be less. And so I would much rather people just install it and they get the best thing possible than to have it built in.
Just as some context for that question, we recently rewrote our Python library to always require requests, and that is our only external dependency nowadays.
That's awesome. And I've also designed it so that you can just stick it into any project and it'll just work, so you can always do that if you don't want the dependency. And it's licensed in a way that allows that as well.
So I have a question about your kind of 90% versus 10%. How do you choose what's in, say, the 10%? And why not say 80 versus 20? Or how do you choose what to include versus exclude?
So if you're asking about the number, I just kind of made up the number. But I know what you're actually asking.
You have to make, those are kind of tough choices, right?
They are.
In the meat of things, and maybe what seems like a good idea at the time, maybe it falls more towards the 90%, right?
Yes.
And then later on you go, no, that was really in the 10%. I mean, how do you go about making those choices to decide your core business activity?
Oh, so for me, like you could approach this very objectively, but I don't think it's an objective problem. I think it's a very subjective problem, and you just kind of have to really, think about it a lot and design it, and you kind of have to use some foresight. And ideally, you can design it in a way so that, you kind of you can always add things, but you can't take things away very easily. So it's important to kind of lean on the side of I can add that later. You can take things away. So for requests, it's interesting. It used to do a lot of things that it doesn't do anymore. For example, it used to have Kerberos authentication built in, but I don't use that. No one on the core team uses that, so we couldn't sustainably sustain that code. So what we did was when we removed it, we extracted it into its own library, and we made sure that request was modular enough so that anyone could insert that functionality themselves. And that was a really good practice. And we've done that for everything. You could actually make, there's adapters. I completely abstracted the send a request functionality, so you can have your own connections, and you don't actually have to even use HTTP. You could use it to send email if you wanted to, or to do FTP or read from files. So being able to, take away things so basically that 10% wanted a bunch of things, and what I ended up doing eventually was making it so that someone else could do that to the library, and that was really powerful to be able to do that, and it's been great. So anyone can write their own authentication, anyone can write their own connection styles, their own connection pool if they want, and that seems to be a really good way going forward, because then you're kind of serving. I'm still serving that other 10%. But just not myself. I'm empowering them to serve themselves, which is important. Yeah. Yeah.
So what resources would you suggest for good API design?
So I personally really enjoy, some of my favorite libraries are, I like requests a lot. I really love Flask. I think it has a fantastic API. I think it's a little hard to approach because it's also kind of fused with this Werkzeug project, but in general, it's really well done. And one of my favorite APIs, it's kind of crazy, is called DocOpt. And so it turns out, if you ever... That's awesome, by the way. Yeah, it really, really is. It's kind of the best thing since sliced bread. So basically, when you want to do command line argument parsing, you're running a command line tool, and you have, you want to have dashes and options and all kinds of stuff coming in from the system args. The default option is arg parse, I believe, in the standard library, and it's really ugly and terrible, basically, in my opinion. And there's so many different options that you can do. But DocOpt, it turns out, is so you have help strings that are printed out when you do -h in a library or a command line tool. It turns out that's an ISO standard, what those different brackets and things mean. And so what you do is with this library, you just write the help string, and it'll parse that, and then it'll parse your arguments from that, and it just works. It's amazing. So you don't actually have to write any parsing code yourself at all. Because there's the angle brackets and the ... dots and the square brackets. They all mean different things, and so he just parses that, and it just works. So that's one of my favorite. For me, it's all about just seeing people that are doing things really well, and then just kind of approaching problems in that way. I don't know of any good books or essays on how to write a good API, but for me, it's all lead by example type of stuff.
Your description of how you handled the 10% that you don't code for sounds like the internals get rather complex.
Can you say that the internals got
complex? The
complex?
internals got complex versus the API.
I could say, are you done?
Yeah.
Okay. I think it's actually the opposite. I think that if I was trying to serve those people and solve their problems, then the internals would be extremely complex. And what I've done is I've allowed the internals to be as completely simple and concise as possible, while still allowing them to step in and inject what they need where they need. And it ended up making the code base much more elegant. I did have to refactor it in order to do these things, but it's superior design than what it was before. So at least from my perspective. I thought I saw one in the back, or maybe not.
Any more questions?
anything at all. There we go.
Hey, thanks for the great talk.
Thank you.
So going back to that, there should be one clear way, one obvious way to do something or accomplish something. It kind of reminds me of the XKCD comic where it's like, well, why are there 6 standards to accomplish or, to format data in this thing? And it's like, we should develop something new. And then there were 7.
The
right?
NIH thing, yeah.
So, I mean, how do we approach that as a community? And then do you think there's any involvement or participation that we need in the PSF?
So basically, I think the way that this is solved is that it's a social problem, not a technical problem, and that the community just kind of gravitates towards what's best. It often seems not always what's best, but like requests is now the obvious answer to doing HTTP. So that seems to be the obvious way to do it. And so I think it's important to have a bunch of different options available. And if one isn't the obvious way to do it, I feel like that either means that someone needs to really believe that it is and share that with other people, or they need to, the right thing hasn't been made yet, or no one cares enough for it to be a thing. And that seems to often be the case, where it's like date times. A lot of attempts have been made to make really great libraries, and they're really great, but there's not an obvious one that everyone uses, and it's because people they don't really care about date time, And so I did this with requests. I extracted all the CA certs that I do in the whole process of doing that, and I made it a very language agnostic project called certify.io. And I'm like, everyone who's making requests on the internet should be verifying SSL against all these certs, and here's the official thing you can use to download this. I was really excited about this project, and it turns out no one gives a shit about SSL certs at all. And so it was pretty funny, because literally no one uses this thing, even though it's really good. So I think it's a combination of both of those things. Like you can rely on the community to pick it, but only when it's the best. Otherwise, someone who really cares about it needs to go and lead the way and tell everyone to use it. And that seems to be what usually happens. So does that answer your question at all? Yeah. Okay, you're welcome.
Question.
So your library is awesome.
Thank you.
The request. Yeah. No, people that I work with that have collectively 50 years of SAS and nothing else were able to combine external data from NOAA and the Fed and stuff to their work projects
awesome.
Easily, in a month.
Sweet.
So you brought Python to them. Yeah.
Cool.
But I have a question. So I've never used Python at work except for tiny little projects like that. But I wonder, in an environment where people are working with Python, people probably have their own Wild West code, their own stuff that they use for themselves. Have you thought about that, or ways that a work community could make their code modular, usable, live beyond their own tenure at the company?
Within the company?
Yeah.
I mean, I feel like an ideal approach to that would be to open source as much as possible. But I know that's not the case with companies, because usually when that happens, they don't maintain it. So actually, the way I like to do it is I like to enable the employees to open source it themselves. And that seems to be a really good approach. So for me, I was working at a company when I wrote this, and I wasn't working on a work thing, but ideally if I was, I could have owned this project and created it and gotten other people involved. And ideally my company could have supported me and helped me do this. And I feel like if that was to happen, then, collectively the community would really be improved. But most companies are really greedy with intellectual property, and you kind of have to do legally gray things in order to do open source. And it's very unfortunate, but I do feel like that would be if you're asking for my ideal answer, that's definitely it. My practical answer is basically to treat internal projects like open source projects. And one of the most important parts of open source is evangelism, really. It's just telling people about it and then having them try it for themselves. And that is true internally too. So ideally, you could get other people in the company to help you make something that makes everyone's jobs easier that isn't part of their core job, So that's kind of my 2 cents, I guess.
This will be our last question.
Excuse me. I just wanted to say something about, you said nobody really gives a shit about date times, and I think that's true until they have to use date times, and then they really care about it a lot.
That is very true.
I was wondering, this is probably an idiot technical question, but I want to be able to experiment more with Python 3, but I don't want to overwrite my OS 10 installed version because I have other projects that link to it and for various reasons that can't really be done in a virtual environment. And I wonder, like, if there's any tips or things for like managing multiple versions of Python and dealing with that, whether it's virtual environments or however it's done.
Yeah, so the best practice is definitely to have multiple versions of Python installed. What I personally do is I use Homebrew, and I install 2 and 3, and they sit next to each other and they don't interfere. One is called Python or Python 2, and the other one's called Python 3. And then when you create virtual envs, you can add a -p to the virtual env. So you can do virtual env -p, and then you give it the name of the Python interpreter to use. And then that virtual environment will only use that version of Python. And that's the best practice. And ideally, it would be really easy to install every version of Python next to each other, and then you could just do whatever you want whenever you want. And that's what I've done for Heroku, for example. But it's a lot. You have to compile them all, and it's a big pain. So really, all you need is latest 2, latest 3. Have them both there, and then when you create a virtual env, use the -p or --python option, and then it does just work. Did you say that you think your projects won't work in a virtual environment?
I have a particular project that is an App Engine. It's like a legacy project. It's on App Engine, and like I have this whole complicated series of things, like even installed into my system Python library folder and everything, just to get everything working on my system, and then be able to push deploy it to App Engine. And
well, that sounds like an App Engine problem.
We've been begging them to migrate
problem.
it to like Compute Engine or AWS for months, but they don't want to spend the money on it, and I can't really blame them. It's not my money to spend. So
yeah, it sounds like an App Engine problem, not a Python problem, I think.
Yeah, I get that.
Okay. Absolutely. So I would, yeah.
But I have newer projects that I still use virtual environments.
Yeah. Oh, I see what you're saying. So in that situation, what I would do is just never trust unless it's for that special project, just don't trust your default version of Python that's on the system. And you probably shouldn't be doing that anyway. So the one that ships with OS X, if you're using a Mac, is like, it's modified pretty heavily by Apple. And so if you're doing like real Python work, you should always install your own Python anyway. And so I would recommend installing Homebrew and then installing 2 and 3 with that, and then just using that for all of your other work, and then just let that other thing kind of exist for that weird project. Yeah.
Just virtualize at a higher level with VirtualBox.
Yeah, you could do that. Use Docker, VirtualBox, and all kinds of stuff.
Really logical, nice alternative to that, especially for people who use scientific and don't want to mess with the library stuff, and that's to download Anaconda.
Yes.
That has all the preloaded stuff, and you can basically fire up an Anaconda 2 or an Anaconda 3 environment, or shut it down and use what you got. And that's a sort of low involvement, nice solution also.
Yeah, and if you're ever dealing with crazy libraries, like if you are in the scientific community and you have to install like SciPy and NumPy and Pandas and all these byte array crazy things that you see, if you use Anaconda, it just works. And they've precompiled everything into their system, and it just instantly installs. And you can even do like Qt, which takes like 4 hours to compile because it has like WebKit inside of it. Like all those things, they've solved a lot of things that are outside of the realm of Python as well. And if it comes, basically when you install Conda, it comes with like 200 packages pre-installed. So it's a very large distribution that like scientists can always count on being there. You can use this other thing called mini Conda, which is like, here's just Python, here's just a couple little libraries, including requests, and then that's all it is, and then all the other things you can install, so you have a minimum install. And it plays well with pip too, so I definitely recommend mini Conda. It's pretty great. And if you use Heroku, I wrote a mini Conda build pack that I'm trying to get people to use, so come talk to me about that afterwards if you want to talk about that.
Thank you very much.
Thank you.